Hey guys, welcome back. Today what we're going to talk about is scientific notation. We're going to convert today from standard form to scientific notation. Then tomorrow we're going to go from scientific notation to standard form. Now, in 7th grade science and earth science, you should have done this topic. If you had me in science last year, I know we did this. But just in case a teacher didn't teach this, or more importantly, you forgot, we're going to do a review. But before we jump into anything, I want to quickly say, if you have any questions when you go to do the assignment, message me on Google Classroom or email me, and I will get back to you. To get back to me for me to get back to you as quickly as possible, make sure you email me or message me on Google Classroom from 8 a.m. to 12 p.m. So let's get started. The first thing we have to talk about when we talk about converting to scientific notation are the two rules. The first rule is your number that you create, this decimal that you create, cannot be 10 or greater. It has to be less than 10. It also has to be greater than 1. So for instance, if I created a decimal like this, 0.00005, this is less than 1, so this cannot count. This breaks the first rule, so this doesn't work. Also, 10.222, this is 10 or greater, so this breaks the second rule. Cannot be 10 or greater. Your second rule is, in scientific notation, 10 is always going to be the base. I know you learned exponents before I got here when you were with Mrs. Smith. And you know the base is the number that the exponent is raised to. Your base in scientific notation is always going to be 10. It's always going to be some decimal times 10 to some power. Those are the two rules to keep in mind. Okay. Now what we're going to do is we're going to practice with an example. So the first number that I want us to look at is going to be 18,700. Now I'm going to write it bigger here so that you see the room. Okay, so when doing this, the first thing I do is I put an imaginary decimal at the end of the number. So at the end behind this last 0. Then I put a decimal where my decimal is going to be created, the decimal that I'm creating. Now, you have to have significant numbers when creating this decimal. You're not going to have zeros when creating this decimal. The next thing is you have to keep in mind the first rule. So if I were to create a decimal that was 18.7, this cannot work because it's greater than 10. But if I create a decimal that's 1.87, this fits the first rule. It's less than 10 and greater than 1. So this works. Notice how I don't include the zeros. You're not going to include any zeros. All numbers that are significant, all numbers asides from 0, will be included when you make your decimal. Don't include the zeros. So I'm going to have 1.87 times 10, our base. And now this is where I have to connect my decimals. So I put my decimal point where the decimal is, I put the decimal point at the end, and then I connect. So I went 1, 2, 3, 4. I went 4 spaces to the left. So my exponent is going to be positive 4. So 1.87 times 10 to the 4th power. A general rule to keep in mind, if your if your whole number, the number that's in standard form, is big, your exponent is going to be positive. If the number is small, your exponent is going to be negative. Another way to look at that, if you're moving your decimal from left to right, it's going to be positive. If you're moving from right to left, it's going to be negative. But the easiest way to keep in mind, if your number is big, positive. If your number is small, negative. So my 18,700 is a big number, so I'm going to have a positive exponent. Now, let's look at another example. I'm going to have 902,000. So again, my number is big. The first thing we're going to do is put a decimal point at the end of my number, and then I'm going to pick the decimal to end with. So again, I have to keep rule number 1 in mind. I can't have 90, I can't have 902 because it's too big. So it has to be 9. And because your 2 is at the end of 0, you have to include 0. That's the only time you're going to do that, because you have to include that other significant number. So the decimal that you're going to have is going to be 9.02. Then we have to count. 1, 2, 3, 4, 5. I'm going from right to left. 1, 2, 3, 4, 5. So it's going to be 9.02 times 10 to the 5th power. This is because, again, I had to move 5 times to connect my decimals. And because I went from right to left, I went to the left direction, it's positive. Just keep, and the other way to think about it again is my number's big, so my decimal's positive. So I'm going to have 9.02 times 10 to the 5th power. Now let's work with a number that's small. The next number we're going to work with is going to be 0.0026. So now I have a decimal already here. Now I have to pick what my decimal is going to be. So again, I need a decimal that's in between the two. So I'm going to have one decimal that's here. I'm going to have one decimal that's here. I'm now going to connect them. 1, 2, 3. So my decimal is going to be 2.6 times 10, 1, 2, 3, to the negative 3rd power. Now you probably by now get why it's 3. I moved it once, twice, 3 times. But why is it negative? For starters, it's a small number. This is a tiny number, 0.00026, 0.0026. It's a small number. Also, I'm going left to right instead of right to left. I'm heading right, not heading left. So that is my answer in scientific notation. We're going to look at one more example. We're going to look at a really small number. We're going to look at 0.0000875. So we already have my one decimal right here. I now need to put a decimal where my actual decimal that I create is going to be. I'm going to put my decimal right here, because by now you understand your decimal has to be greater than 1 and less than 10. I'm now going to connect my decimals like usual. 1, 2, 3, 4, 5, 6. And I went left to right. So my decimal that I create is going to be 8.75. I'm including all the significant digits times 10. And I went 1, 2, 3, 4, 5, 6. So it's going to be negative 6. And that is going to be my answer. Again, it's negative because I went from left to right, and my number that I started with is a small number. So my exponent is going to be a negative. So this is going to wrap up the video for today. If you have any questions when you're doing the assignment, please message me on Google Classroom or email me. Have a wonderful day. I'll see you tomorrow.